Okay, so here we want to talk about this other topic, and that's the topic of solving a quadratic equation by completing the square. Now, what you'll notice is different about this equation from the other ones we were solving is that we not only have a term, an expression that's being squared, but we also have an x term. And so the way that we work this is a little different from what we've been doing. So the first thing I want to get is first thing I want to do is isolate the variable terms on one side of the equation. So the variable terms are 3x squared and 3x. So I'm going to subtract 3 from both sides of this equation. So it becomes 3x squared plus 3x equals -3. Now I want to complete the square by adding half of the coefficient of x to both sides of the equation. And I don't want to do that until I have x squared plus bx on one side of the equals. And notice I don't have x squared plus bx, but I have 3x squared plus some number times x. So if you don't have a simple x squared here, you want to divide all terms of the equation by whatever your coefficient of x squared is. So this becomes x squared plus x equals to -1. So notice my coefficient of x is actually an unwritten 1. So I'm going to make that green. That's unwritten, okay? But you have to understand that there's a 1 there that just is not necessary to write. So half of 1 is 1/2. I take half of b and square it. But notice whatever I added to the one side of the equals, I have to add that same thing, and let's maybe use colors just to highlight this. I have to add the same exact quantity to the other side of the equation. And notice I very carefully picked the quantity I'm going to add on, because I want the one side of the equation with the variables to become a perfect square trinomial. Now if you factor this, this factors into the square of x plus 1/2. Over on this, so the left side of my equation is a perfect square trinomial. I made it become that by adding on the number needed to make it a perfect square. So now what I'm going to do is I'm going to actually square this out on the other side. The square of 1/2 is 1/4. And when I add -1 to 1/4, I have to think of -1 as -4/4. So I think of -1 first as -1/1. And then I multiply the numerator and the denominator by 4. So that both fractions have the same denominator. So this is -4/4 plus 1/4, which is -3/4. So I have the square of x plus 1/2 equals negative 3 over 4. So I'm going to eliminate the exponent of 2, which is applied to x plus 1/2, by applying plus or minus the square root to whatever is on the other side, whatever the real number is on the other side of the equation. And that real number is negative 3/4. So this is x plus 1/2 equals plus or minus the square root of 3 over the square root of 4 times the square root of negative 1. So I've broken that up into 3 radicals. I apply the radical to the 3, to the 4 in the denominator, and to the negative 1. So x plus 1/2 equals plus or minus the square root of 3 over 2 times I. And I'm going to add a negative 1/2 to both sides to get x equals negative 1/2 plus or minus the square root of 3 over 2 times I. All right, and so now I'm ready to write my solution set. Which is the set containing, and let me move down a little bit so I have enough room. All right, so my solution set contains negative 1/2 minus square root of 3 over 2i, negative 1/2 plus the square root of 3 over 2i. All right, now I have another similar problem where I want to use the process of completing the square to solve my equation. So let's get the variable terms on one side. 4x squared plus 16x are my variable terms. And we're going to subtract 4 from both sides to get our constant on the other side of the equals. I want to make sure before I move forward the coefficient of x squared is 1. It is not 1. So I divide all terms of the equation by whatever the coefficient of of x squared is. So x squared plus 4x equals negative 1. So in this case, my b is 4. So I'm adding on to both sides of the equation half of 4 squared. And notice you're always adding that on. Half of 4 squared. That's what I'm adding to both sides of the equation. So half of 4 is 2. So I'm actually adding on 2 squared. And I'm adding that to both sides of the equation. All right, so on the left side, I leave that as 2 squared because that helps me to see that this perfect square trinomial that I formed factors into the square of x plus 2. which equals negative 1 plus 4. So the square of x plus 2 equals 3. So I can lose this exponent of 2 applied to the x plus 2 if I take plus or minus the square root of 3. And that equals x plus 2. And I am going to add a negative 2 to both sides of the equation. So x is negative 2 plus or minus the square root of 3. So that's my method called completing the square. So my solution set contains negative 2 minus the square root of 3, negative 2 plus the square root of 3. That's my solution. All right, now